Let me do this integral by two different methods. Now, method one, obviously that we won't get rid of a square root, so we use the substitution that let u be square root 6 minus x. We hope that it can it can get rid of all the square roots. So this integral becomes this is a u, right? U, yeah. This becomes u plus 3 plus x. Now then here is x is equal to 6 minus u square. Okay, so 3 plus x, that will be 9 minus u square, right? And dx will be negative 2 u d, right? Okay, I'll have to write very carefully now. I try to avoid any kind of mistake. Here, when x equals 0, u is equal to square root. When x equals 0, u is equal to square root 6, right? Yeah. When x equal to 3, u equal to square root 3. All right. Then I change this negative for switch it out, right? To switch the limit, it becomes square root 3 to square root 6. So that negative is gone. Is u square, u plus 9 minus u square, 2u square. That's correct. Okay, good. No square, nothing. Now here, I'm using substitution. Let the u be 3 sine theta, right? I try to get rid of the square root. Now this one is equal to, this will be equal to, u square would be 9, right? There's a du. 9 sine square. Du will be 3 cosine square, so it will be equal to 18. 9 times 2 is 18, right? Sine square, and du will be 3 cosine theta d theta. Good. This will be 3 sine theta plus, this is 9 sine square, so take 3 out and cosine. Okay, very good. Now the problem is to convert these limits, root 3 to root 6. Let me write here, okay. Now, when u is a root 6, okay, here I converted the root 3 to root 6 by angle, right? Say from beta to alpha. Now, what is alpha? Sine alpha sine alpha when u is equal to root 6. It will be equal to root 6 over 3, right? Root 6 over 3 is equal to square root 2 over 3. So, okay, I know this alpha is an angle converted from u equal to root 6. But for time being, I just keep writing alpha instead. But I know that what is alpha? Sine alpha is root 3 when u equal root 3. Similarly, that sine alpha, sine beta is a value when u equal to root 3. Okay, u equal to root 3 is equal to, according to this, is 3 root 3 over 3. Yeah, root 3 over 3. This is equal to 1 over root 3, right? Good. Now, I tried to find the relation between alpha and beta. Okay, alpha. Sine alpha, say this is alpha, right? The sine alpha is a root 3 over root 3 over root 2 over 3. Root 2 over 3 is sine alpha. And this square, this is 1, right? And sine beta is a 1 over root 3. So this will be beta. This will be beta. You know, it's a very, very, very strange that alpha and beta just is make it half pi, you know. Alpha plus beta is half pi. So that's the relation. Okay, now, then what? Here is this one is equal to 3 cancel out. It's 18 out. From beta to alpha. This will be sine theta plus cosine theta. This will be sine square and the cosine theta and d theta. Okay, that is our new integral from the original one after make 2 substitutions. Then what? Here we solved the problem of square root, but now we come up new problem. Now this is still some kind of a problem, okay? Now? But here I have an idea that because cosine and sine can be switched, you know, if the angle is half pi, the difference. So I let theta is equal to half pi minus t. I introduce a new parameter t. Then this, okay, I'll write slowly because I don't want to have any mistake. The cosine square becomes sine square becomes cosine t, right? Because obvious reason, this becomes sine t. This becomes cosine t. This becomes sine t. And d theta is a negative dt. All right? Now, when theta is alpha, t will be half pi minus alpha. Half pi is beta. So this becomes beta. Same thing, okay, when theta is equal to beta, t will be half pi minus beta. Half minus beta is alpha. Okay, then I switch these two by changing negative, right? So this becomes beta to alpha. And here, t is just dummy variable. I can write x, so the cosine. I can write theta, square theta, sine theta, d theta, right? Negative is gone. This is a cosine theta plus sine theta. All right. Okay, this is my integral, which is equal to this one, because this one comes from that one. These are same. These are equal to I, you know, right? I is equal to this, and we just keep developing, become this. So these two also I. These two are also i's, you know. Therefore, 2i's is equal to this plus this. This from beta to alpha. This plus this, right? This cosine theta plus sine theta. And this plus this. This plus this. 18 is out. Okay, 18. Where is that 18? Okay, 18 is there. 18 is there, right? 18 is out, and this plus this plus this. And you have a common factor. Sine square cosine. Cosine square sine. Therefore, sine theta, cosine theta is common. Common factor. And then left over sine theta plus cosine theta, d theta. All right, I need a new paper. Now, 2i is equal to 18, and this is cancelled out. 18 from beta to alpha, and the sine theta, cosine theta, d theta. All right. I hope everything is okay. Then this one is equal to 18. This is from beta to alpha. This is a sine theta. This is a d sine theta, right? So this integral is much easier. 18 and half sine square theta, right? And from beta to alpha. Okay, so this one is equal to 18 times half sine alpha square minus cosine square beta, right? This one is equal to 9 multiplied by. We know that sine alpha is square root 3 square 2/3. So this one is 2/3. Because we know that before, okay. Sine beta is square root to 1/3. It's minus 1/3 after square, right? After this is sine. Sorry. Sine square minus sine square. Okay, this one, yeah, this is equal to 1/3. So this is 3. That means 2i. 2i is 3. So I is equal to 3 halves. So that is my solution to this integral. Okay. A little complicated, you know, but I think I try to write very clearly except some errors here. Okay. Now this is method 1. Okay, method 1. Method 2, it's much easier. Method 2, let me write this way. From 0 to 3, square root 6 minus x. Wait a minute. This is a square root 3 plus x plus the square root 6 minus x dx. Our method is a much easier. You know, I introduced the new variable is u minus u is equal to 3 plus x. 3 minus x. 3 minus x. Okay, then x is equal to 3 minus u, right? Now our integral becomes this is 6 minus x. 6 minus x is 3 plus u, right? Yeah, square root. And this becomes 6 minus u. 6 minus u square root. Because x is this. 3 plus the 6 minus u, yeah. Plus 3 plus u, right? And dx is a negative du. Okay. When x is 0, u is 3. When x is 3, u is 0. Right? So this, I let the negative change this limit from 0 to 3. So negative is gone. And this becomes 3. Now because u and x is just dummy variable, I can change it to x, right? So this is 6 minus x plus 3 plus x, yeah, dx, right? Negative is gone. So this is also equal to I, you know, I is from beginning, right? So this is I, this is also I. This is I, this is also I. Therefore, 2I is this plus this, right? Is this plus that. So it becomes from 0 to 3, this is 6 minus x, 3 plus x plus 6 minus x plus this. 3 plus x, 6 minus x plus square root 3 plus x, altogether dx. And fortunately that the numerator is the denominator after adding, right? So this becomes 0 to 3 and the dx. And this one is equal to x. From 0 to 3 is 3. Therefore, I is equal to 3 halves. See? That is much easier. Okay, this is the second method. I think this is a very good method. Thank you for your watching.